standing here in my kitchen today because I want to talk to you about measurement. And what better place is there for measurement than the kitchen? I've got my 2-liter bottle of soda. I got my bottle of oil here, 1 gallon, but that's 3.78 liters, 5-pound bag of potatoes, pound of coffee, a dozen eggs, lots of different teaspoons and tablespoons for measuring, cups, half cups, quarter cups. When you work in the kitchen, you do a lot of measuring all the time. Even the temperature on the oven and the temperature on the refrigerator has to be measured. But how do we do measurement in the chemistry laboratory? Things are done a little bit differently, but not a whole lot differently. So let's take a look at how you're going to measure length, volume, and mass. Let's say I wanted to measure the length of this king of spades. And I have a centimeter ruler here. I'm going to turn this over. So let's say this is the ruler that I've been given, and it measures length in centimeters. And also notice we have lines at the midpoints, or halfway marks, between each centimeter. So this would be 0.5 centimeters right here, 1.0, 1.5, 2.0, 2.5, and so on. So if I go to measure this card, I want to measure the length of my king of spades. I'm going to line that up with the edge of the ruler and see where the other end lines up. Now notice it is not quite 9 centimeters. It's a little short. So that means we're going to have to estimate tenths of a centimeter here on our ruler. So I'm going to just slide this down a little bit. And I'm going to make a little pencil mark there so I can see where the end of the card is. So if I make a little pencil mark or hold my pencil point there and then take it away. So it's pretty close to 9. It's a lot further away from 8.5 than it is from 9.0. So I would record 8.8 centimeters for my measurement for the length of that card. Now, what if our ruler was a little bit different than this one? What if it looked like this? Now we have a lot more lines to use to get our decimal. And in fact, this particular ruler has tenths. So once again, if I line my card up, and I look at the end here, it's lining up right on 8.8. So it's right there. So since it's exactly 8.8, when I record this length on my answer sheet or on my lab sheet, I'm going to record 8.80. I want to put a 0 on the end to indicate that I know that it's exactly on that line. If it was a little bit in between 8.8 and 8.9, these two lines right here, I would record 8.85 centimeters. So whenever you're measuring a length, your last digit needs to be your estimate, or if it's an exact measurement and it's right on a line, that last digit should be a 0. Okay, now we're going to talk about measuring mass in the lab, and this is one of the digital balances that we have, and typically this is what they look like. There's a metal pan here, and so the first thing you want to do is clean that pan, make sure that there's nothing on there. The metal pans actually come off, so you can actually take those off, rub them off with a paper towel, and then you can set those right back on. You don't want to do that while the balance is turned on, however. Now, once you have the pan seated, it's nice and clean, then you want to turn it on. Here's the on-off button right here. And be patient and wait. It's got to boot up. It's a little computer, so you must wait. And when you see the 0.00 grams, there's a little G here that stands for grams. When you see that, you know you're ready to go. If this doesn't say grams, if it says some other unit, call your teacher, because we have to change the measurement units. These balances can measure ounces and all kinds of things. So you should have a G there, and you know you're ready to go. Now, these balances need to be calibrated. There's directions for balance calibration on little cards that are located near the balances. Just follow those directions. You want to calibrate every so often. Sometimes these balances drift off of the 0 mark, and they need to be calibrated to make sure they're still measuring accurately. Now, before you do anything, you want to zero the balance. So there's a button here that says 0. So you press that, and then you wait, and it will reset to 0. Now, let's say I wanted to measure the mass of this bolt. So I just place that on the pan. And I wait. When you see this little symbol over here, the two little triangles connected with a line, that means that it's finished. So you would record 28.55 grams for the mass of the bolt. Sometimes you'll notice that the hundredths place will go up and down a little bit, and that's because the balance is estimating that last digit. We know for sure that the mass of this bolt is 28.5 grams, but we're not 100% certain that the last decimal place is a 5. It could be a 6. There it goes. You see that? It just changed. Or it could even be a 4. So these balances are said to be plus or minus 0.01 grams because that last decimal place is uncertain, plus or minus 1 unit. So keep that in mind later when we start to talk about significant figures. Now let's say you wanted to measure the mass of something like salt. You can't pour the salt right on the pan. You have to put it in some kind of container. And you don't want the mass of the container. Now these balances have a very nice feature, and it's called the Tare button, T-A-R-E. And on this particular balance, it's called the 0 button. So if I want to subtract the mass of my container, this cup, I place that on the balance, and then I press the 0 button and wait. And you'll notice the balance resets either to 0 or 0.01. So notice if I take the cup off, it shows the mass of that cup, but there's a little minus sign over here. So that means it's going to subtract that amount off from whatever I put in that cup. Okay, so I'm going to put that back on there, and then I can put in the cup whatever it is I want to mass. So let's say I want to mass some salt. It's best to take it off so you don't spill any salt on the pan, because then you'd have to start over if you did that. And I'm going to put that on there. So there's my salt. So I'd record the mass there as 3.84 grams of salt. So that's how you use our digital balances. Okay, so let's talk about how to measure and record volumes in the lab. I have here a graduated cylinder, and in that graduated cylinder I've put some water. Notice the surface of the water looks red, and it also looks like it has sort of a thickness to it. The reason why it looks red is because the base of the graduated cylinder is red, and it's reflecting the light, the red colored light, up to the surface of that water. Also, it kind of looks like it has some thickness to it, and that's because the surface of the water is curved. That curved surface is called a meniscus, and it usually happens when we have a glass container. We always read at the bottom edge of that meniscus. So this red color actually is helping us see where the bottom edge of the meniscus is. Now let's look at the scale. This is a 100 milliliter graduated cylinder. This line here is 60. This line here would be 70 milliliters. So halfway in between, this big line here would be 65 milliliters. So each line is 1 milliliter. Every time you use a graduated cylinder, you need to look at the scale and see how it's divvied up and what each line would mean. so that you can record the correct volume. Now, the bottom of the meniscus is lined up with the second small line past the 65. So we would go 65, 66, 67. So there's 67 milliliters of water in this graduated cylinder. Now, you do not record 67, you record 67.0. Always record all volumes to the nearest tenth of a milliliter. Therefore, if it's in between these lines, let's say if it's between 67 and 68, you would record 67.5 milliliters. So you're always going to record every volume to the nearest tenth. If it's right on a line, make that tenth a 0, but you must do that for every recorded volume that you do. Now, let's say we wanted to get the volume of some odd-shaped piece of metal, and you're going to be doing this a lot in labs. So I have a bolt here. So how would we get the volume of this bolt? Well, we could use a process called water displacement. So right now, my water is sitting at 67.0 milliliters. And then what I'm going to do is carefully slide my bolt into the water. Now you want to do this carefully because this is glass, and you certainly don't want to break the glass. I'm going to tilt it a little bit. Okay, and kind of shake some of the air bubbles out of there. Now let's look at our new volume. Well, it's a little bit above the 70 mark, but it's not quite to 71. So we would record 70.5 milliliters. Now, what's the volume of the bolt? Well, we're going to take the 67.0 and subtract that from 70.5. So 70.5 minus 67.0. So the volume of the bolt is 3.5 milliliters. So it's the difference between the two water levels. And that is how you do volume by water displacement.